Hello and welcome to this lesson on the electric motor. This is an application of the motor effect, which we've looked at before. The motor effect being the phenomenon where a wire carrying a current within a magnetic field experiences a force, and we can calculate or work out the force using Fleming's left-hand rule, and we can actually work out the size of the force using the F-Bill equation. Now I've got a simple DC motor here. I'm using a direct current supply here. I could be using a battery power pack, and there's an insulated wire here and a magnetic field on the outside. When I pass a current through the magnetic field and give it a little start, it will actually start to rotate. Now I can adjust the speed of this motor by the current, and so if I increase the potential difference on my power supply, it does start to go faster, because the greater potential difference means there's going to be a greater current through the wire, which means there's going to be a greater force on the wire, meaning it's going to accelerate. To show you the strength of the magnetic field actually makes a difference to the speed of the motor. So if I use a very weak magnet to start with and push it to start it going, it will continue to go, but it's going to go at a very slow rate. Now going to the medium strength magnet, it will go and be able to go more quickly. And over here I've got a very strong magnet, which even with the same current makes sure it goes much faster. The other thing I want to show is that by changing the direction of the current, we can change the direction of the motor. Or I could change the direction of the magnetic field, and it changes the direction as well. In this close-up of the motor, I hope that you can see that the coil is spinning. Now the wires aren't getting tangled because they're connected to the supply via two brushes and a split ring commutator. As I bring this to a halt, you should be able to see the two brushes here. Now these brushes on my motor are made of metal. They might be made of graphite, which is a conductive form of carbon, and you can see where they actually connect to the moving parts of the motor. This is again a copper ring for good conduction, but there's a split in it. The job of that split ring commutator is to reverse the direction of the current in the coil every half turn, and as we change the direction of the coil every half turn, it means that the force is in the same direction and enabling the motor to rotate in the same direction all of the time. So to summarise, the electric motor is an application of the motor effect. We can change the speed of the electric motor by changing the current. We can change the direction of the motor by swapping the polarity of the current, and we can change the speed of the motor by having a different magnetic field, a stronger or weaker magnetic field, and we can change the direction of the motor by changing the direction of the magnetic field as well. And it's really important in GCSE questions to remember how that commutator, the split ring commutator, works. Thank you, goodbye.